Wait, let me jump in.
We back.
Oh, what's up, everybody? My name is Naya Thomas. I'm in the book. Bang. Okay, I'm done.
Oh my God.
Make sure y'all stay in school and go to college. Oh yeah, Queen _Renee 918 on Snapchat.
Go on now.
Hi everybody.
Over.
I don't know nobody.
Yo, if we run out of time this video, you know who to go flame on the book.
Yeah, no
okay.
Hey guys.
All right, nomenclature. Now we knew how to draw them from last video, video 5.
Right.
Now we need to learn how to name them.
You had a formula. We drew how the bonding happens. Now we're going to take them and go to the next level and actually name them, and then use a charge cancellation rule to figure out a formula from the name. So the last one was just showing pictures about how these atoms ionically bonded through the transfer of electron. Now we're taking the formulas and naming them, then taking a name and figuring out the formula.
You got it. Sounds good. So nomenclature of ionic compounds. There are 3 examples. You might just want to watch this one time and get a feel for it before you decide how to write it all down, because it's all going to be flying into one space, and I got to make sure you guys have enough space. So I'm sure you can condense it.
So the first name, middle initial, last name is the general formula for all names of ionic compounds. The first name is going to follow a certain rule.
Right.
An example, FeCl2. We got to name this stuff. So the first name is going to be the name of the metal. Period. End of story.
Yep.
Every single time.
Straight up, no change.
Fe,
iron.
Iron.
Got it.
The next part, we're going to do the middle initial. This is a Roman numeral that's the charge of the iron when more than one oxidation state exists. In the transition metals, we see +2s, +3s. There's a varied amount. So we might have to figure that out last. In this case, we're going to tell you
It's 2.
It's the Roman numeral 2. The iron is in a +2 oxidation state in this example. Okay.
Later in the video, we'll make sure you know how to get back and check this.
I'll write it on the board while you finish that up.
Cool. And then the last piece is to take the last name, which is the nonmetal. Okay. The nonmetal is going to end in that suffix "ide," like we did in the lab. We had to name all the chlorides. So the chlorine, I'm going to lose the E, and it's going to become chloride.
So now I'm ready to explain why it's the Roman numeral 2. Chlorine has only one oxidation state. It's -1.
Correct.
And there's 2 -1s.
So the total charge is -2.
Which means I need to figure out what the iron would be in order to cancel a -2. And it's got to be a +2. So that's my option.
Right.
And that's where the Roman numeral 2.
The periodic table is going to give you
Comes
+2
from.
or +3. And we know to pick +2 because the total negative charge is -2. We got to cancel out the negative charge. That works out perfectly.
We got a couple more examples.
Yeah, we do. So first one is just iron 2 chloride. The next one's a little bit easier. I got CaCl2, same structure. First name is just the, what again?
Name of the metal. I'm going to draw out the bonding while you're talking through it.
Dig it. And in this case, though, when I look at calcium, I see that it only has one choice for an atomic number, for the charge, the oxidation state, +2. I did misspeak. So I don't need a Roman numeral. If there's no choices, I already know what it is. If there's only one choice, I mean, there's not multiples. So I'm just going to take my metal, call him calcium, take my last name, my non-metal, it's chlorine, and chlorine is going to become chloride, just like last time, except for I don't need a middle initial now because there was only the one choice for calcium.
Calcium only has one option.
So I know what it is. I don't need to be told.
If you put a Roman numeral 2 in there after calcium, I'm not sure you'd technically be considered wrong. It just wouldn't be as good as we want it.
Yeah, it does imply that there's a choice then, and there isn't. So that's kind of like too much information. Now, polyatomics, the only hard part about this for you guys right now at this point is recognizing that CO3 in parentheses, which is your giveaway, it's in parentheses, is itself a polyatomic ion. Once that's the case, it's just metal and then the name of the polyatomic ion, which is going to end up being calcium. And CO3 on table E is, let me guess, carbonate.
Carbonate, yes.
Put it together, and it's calcium carbonate. I don't change the last letters on a polyatomic. I just write them exactly how they are in table E. Helps.
Let me explain what people will do because they weren't paying attention to table E. Okay. Some of you will name this calcium carbon oxide. Totally wrong. Because you didn't realize that the CO3 is a polyatomic ion that has its own name. You're going to screw it up. I'm going to tell you to go watch the video again, and you're not going to like that. So pay attention to your polyatomic ions.
Those parentheses really help give you a clue. And they're actually not needed if there's only one CO3. So sometimes they'll be there while we're getting good at them. You got to get good at recognizing the polyatomics on table.
For sure. So now, charge cancellation technique. This is where pictures of those ABCDs really come into play because it helps you figure out the charges and the formula back. Because the name sodium chloride doesn't tell you how many sodiums or how many chlorines.
Nope.
So you actually have to work it backwards, and
that's what we're gonna do. It's all actually, it's all animated.
All animated?
Yep, it's all animated. So I know sodium is Na,
Mm-hmm.
and I know chlorine is Cl.
Correct.
Good. I'm going to use the periodic table to see what is the charge. And the charge for Na is just going to be
Plus one.
+1. And the charge for chlorine then is just going to be, is it a -1? So now what we do is we crisscross them down.
Mm-hmm.
We don't bring the charges, we just bring the numbers. And that's what it says right there. Number only, magnitude, because that tells us how many of each. We can't have a negative atom. We either have it or we don't. So the 1 is going to come there, and the 1 is going to go there. And we put it together, and we got 1 for 1 NaCl.
Right. So we simplified the subscripts because they're both 1-to-1 ratio. Remember, a chemical formula is just a ratio of this element to that element.
How many whole numbers? Correct.
Mm-hmm.
Another example. You want to walk them through this one?
Sure.
Oh, it's all animated.
It's animated? Oh, okay.
I like me drawing.
I know.
But elements, so I got a calcium and chlorine.
Okay.
Now, calcium off the periodic table is always a +2 ion. Now, chlorine, in this case, is going to be a -1. Now, you see here, there's a calcium with +2 and a chlorine with a -1. You actually need 2 chlorine -1s to cancel out 1 calcium +2, which is why you drop the charges down and get rid of the signs, and you get the formula out of it. It's actually a shortcut that we're teaching you, CaCl2. So if you really wanted to do
algebra out,
I would
there's really
actually
no reason.
just draw atoms, brackets, and charges. I would have drawn 1 Ca +2, a Cl with a -1, and realized I need another Cl. So I would have drawn another one. Then I would have counted my atoms and gotten to the same answer.
So here's the perfect place for us to talk about one other thing that we haven't mentioned, that we just so haven't mentioned yet. Chlorine has a number of oxidation states. It's got -1, +1, +5, and +7. Choosing which one is actually easy if you know this particular rule that we haven't mentioned. The first atom is always positive, the second atom is always negative. And when we know that, the Cl, I know I have to pick as a -1 because I need a minus charge.
While Mr. Milks was explaining that, I drew exactly how I would do it. That's not the charge cancellation technique, but it is the charge cancellation technique. It's not the crisscross drop down. It's actually the draw out and count. I've got 1 Ca and 2 Cls. That's how I get to the same exact answer.
Correct. Okay, I think we got 1 polyatomic.
Yep. Iron 2 oxide. Nope.
Right.
Nope.
So it's not. It's even better though.
You
because
do
now
the
I have
click
my
while
iron.
I draw my draw. And
Oh,
see
okay,
what
you-
makes better
okay.
sense to you.
Okay. So I see iron, but I need to know, and I have oxygen. Now I need to know the charge on iron. It could be +2 or +3. In this case, I know it's +2 because the Roman numeral told me so. The Roman numeral is the charge. Okay, so then I have oxygen. Oxygen's negative is always a -2. When I crisscross these down, I get a 2 and a 2. But I can turn this into Fe0 because I need one of each to cancel out. Those numbers reduce down to 1 and 1.
In this scenario where you do it my way, which is you cancel the charges by looking at how many of each you got, you never have to worry about reducing the subscripts to their lowest common factor. Mr. Milk's method with the cross down works every time too, but there's an extra step of, am I in the lowest common factor for my subscripts?
True.
So that's all. I'm just showing you another way.
Just another way. It takes up a little bit more paper, but it's all good, whichever way you like. And ooh, wait a minute.
That's all, folks. See you in practice time. Find a button and I turn it off.